In this video, I'm going to introduce the Urspring by Seccua. This is one of the smaller platform ultrafiltration systems that are designed and manufactured in Germany. The Urspring is a filter that will filter down to 0.01 microns in size, which is used to remove Legionella and other form of microbiological contamination from your water supply. This also includes turbidity, silts such as colloidal silts, also known as rock flour, and other forms of sediments to provide crystal clear and microbial-free water for your facility or your home. While Seccua manufactures a wide range of sizes in their ultrafiltration system lineup, this video is going to focus on the Urspring, one of the smaller platform sizes. The primary markets for the Urspring system are dental practices, healthcare settings such as MDR or Medical Device Reprocessing, labs, and also residential applications. The Urspring also has hot water rated membranes available for hot water recirc systems to reduce bacterial loading such as Legionella in domestic or process hot water systems. Because of the fine filtration rate on these systems, they have excellent removal rates of small particulate matter and bacteria and viruses. So you can see on the spec sheet here, they're rated at well over 4 log reduction for virus, bacteria, and parasites. So let's take a look and see how the Urspring works. So you can see on the system, at top you have your control head and your water connections in and off the side. And where you have is off the valve block on the left here would be your 3/4 inch inlet supply. And off the right side you have your 3/4 inch outlet treated water and also your drain connection, as these do have a periodic backflush, which we'll talk more about shortly. To see how the Urspring provides its 0.01 micron filtration rating, let's take a look at the inside of one of the membrane housings. So here you can see the fiber bundles placed inside the PVC housing. And for a closer view, we can switch over to this picture which shows the myriad of these individual fibers. The raw water will actually enter through the center or the middle of each of these individual fibers, and then microscopic pores will allow the water to push out to the housing, which is then collected via the collector assembly and passed downstream. It's by having an incredibly high surface area, by having all of these fiber bundles, that allow the Urspring system to have a relatively high flow rate for a small-sized ultrafiltration system. And because the Urspring filters to such a small pore size, the results speak for themselves. So this is an example of the before and after water quality of a single pass through a Urspring system. This particular example is taken from a hospital during construction. The original source water was city water, but in this recirculation system, they'd had a contamination event and weren't able to filter the water back to its original state using conventional treatment. And so 2 Ursprings were used on a side stream setup to filter out the entire loop and to bring the water quality back to an appropriate quality that they could hand over to the client. Now, installation of the Urspring systems is quite straightforward, and we highly recommend contacting our office for any new installations and or design advice. But typically, you'll have pre-treatment first, if required, based on the application and the feed water quality, which may be as simple as just a pre-filter, a mesh strainer or sediment filter, followed by the Urspring. And we typically will recommend a small inline pressure tank immediately after the ultrafilter, which will make the Urspring's backflush much more efficient and effective. While horizontal mounting of a Urspring is technically an option, we highly recommend a vertical installation if possible. It'll provide much easier access for maintenance and will provide significantly less strain on the membrane housing unless mounted properly. I'd like to spend a few minutes talking about one of the common applications of the ultrafiltration technology, which is Legionella removal. So Legionella is a bacteria that's quite commonly found in our environment, our drinking water, soil, and whatnot. And it's not a risk to humans traditionally through ingestion, but only when it becomes aerosolized and we breathe it straight into our lungs. The scientific community is finding that in the last few years, it's become obvious that Legionella issues are becoming underreported because they often present as severe pneumonia, and the Legionella bacteria themselves aren't necessarily identified unless you get a cluster. And so even though there are already thousands of people identified as being killed by Legionella annually, it's suspected that the numbers are far higher. So a little bit more about Legionella and where it's found. So Legionella is present in all of our piping systems, water systems. So they breed and they replicate in the biofilm that grows in all water systems. So you can think of biofilm as the growth medium or the food supply for Legionella. So as you're probably well aware, biofilm can be found in piping systems pretty much anywhere. It's hard to eliminate, and it provides that growth mechanism for not just Legionella, but other forms of bacteria as well. There are a number of factors that will determine how positive a growth medium your water system might be for bacteria. So some of the three key variables are pH, nutrient supply, and temperature. So the greater the temperature, up to a point, it becomes a very positive growth medium. Consistent nutrient supply, of course, provides the food for that bacteria to grow, and the pH is a critical component, which is much harder to adjust in a water system. And so with an incoming supply of those microorganisms, such as Legionella, you'll find that they very quickly start to form colonies and then complex three-dimensional structures, which make these quite difficult to remove with some of the other conventional forms of treatment. So as these three-dimensional structures build up, and here's an electron microscope image showing the complex structure of some of the biofilm, you can see how difficult this can be to break up in pipes. And there's plenty of evidence of biofilm growth, which you've probably also seen in your everyday life. So often shows up as a slimy substance, which will sometimes come out of fixtures or faucets, or you'll find in various plumbing components. Here's another close-up picture of some of that biofilm growth. If we look at two of the more common treatment options used conventionally for Legionella, we can look at things like chlorination. Chlorination can be effective in free-flowing water systems, but has a serious limitation for Legionella and biofilm growth, as we see in water systems all over the world. The use of chlorination has some pretty serious efficacy issues with trying to disrupt biofilm growth. Things like pH and water temperature and decreasing chlorination levels in aging systems present some pretty serious issues. And if you actually look at a cross-section of a pipe, so the pipe wall being here, the biofilm growth on it, just like you'll see increased water flow or speed of flow through the center of the pipe, you'll see the same effect with chlorine concentrations, as the biofilm will actually degrade or use up your chlorine. You'll see a lower concentration of chlorine at that boundary layer. So it really doesn't do a great job of disinfecting and disrupting that biofilm growth. And at the same time, because the biofilm can be quite thick with that complicated three-dimensional structure, chlorine has a really hard time penetrating deep enough to provide the treatment required on a long-term basis. It's because of this that short-term, high-concentration chlorination shocks will be used, but even those have limited effectiveness if there's a serious biofilm layer growth. Another common approach to try to deal with Legionella growth in biofilm is through hot water shocks. Hot water shocking of piping systems has been used conventionally as a deterrent for that growth. Studies have shown that when Legionella is presented with hot water, that it actually has a bit of a sleep mode or a dormant state. So the hot water shock can kill approximately 80% of Legionella, but with its dormant state, around 20% seems to remain active. And some studies have shown that even though a traditional plate count method of checking the bacteria levels after a shock showed no active Legionella, using flow cytometry methods will actually still show bacteria counts even up to a 60-minute shock at 158 degrees. Flow cytometry is a method of checking bacterial counts in water samples by evaluating the individual cell characteristics of those cells rather than the standard plate count method, which essentially just counts growth via colony forming units. And if bacteria is in a dormant state, you wouldn't get a plate count result, whereas with a flow cytometry test, you could still see the characteristics of those individual cells and determine whether or not they're still active. Using a Seccua Urspring system is another weapon in your arsenal against bacterial growth through biofilm. Here you can see a generic cutoff diagram showing the ultrafiltration rate at 0.01 microns compared to some of the other more traditional methods like screens, sand filtration, or microfiltration. And at different lengths along that diagram here, you'll see the different things that are removed, or colloidal bacteria and viruses. And what ultrafiltration will remove is everything above 0.01 microns, whereas dissolved salts and metals and minerals will still pass through. So without changing the chemistry of the water, you can provide your microbial or your silt reductions. Another way to see that is with a close-up scan. So here you see some bacteria, E. coli and Legionella, up against the background, which is the pores of the individual microfiber elements in the Seccua system. One of the common applications for the Seccua ultrafiltration systems are dental clinics. The individual water lines that feed the individual chairs are so small that they're extremely hard to disinfect, and they are very highly susceptible to biofilm growth and the Legionella that comes with that. So a number of years ago, Seccua actually did a case study in a dentist's office in Munich. And essentially what they found was that after 8 weeks, they had an 82% reduction in background bacteria counts or total plate counts and a 100% removal of Legionella. Extremely high removal rates after 2 months of operation. And we can see through some of the results charting the bacterial counts from the date of installation, you see a steady, consistent drop in those bacterial levels. And that's a simple function of removing the food source or that nutrient stream and any new incoming bacteria. So I urge you to contact our office if you have any questions on the Urspring or the other size systems in Seccua's lineup, and to consider this as another tool in that arsenal for Legionella control in both hot water and cold water systems. If you have any questions on these systems, whether it's application or efficacy or design questions, feel free to shoot us an email, info@watertiger.net, or check out our website, www.watertiger.net, for more information. Thanks for your time.